welcome to our session on developing fast and efficient data science while ensuring security and compliance. My name is Natasha Fort, and I'm a machine learning specialist here at AWS. I have been with AWS for about 1 year, and I worked mostly with public sector customers to help them build enterprise machine learning workloads on AWS in regulated environments. My recent interests include operationalizing the machine learning workloads and focusing on enabling data science team to be more agile thanks to automation, which is something we'll dive right into today. I'm here with my colleague Eden, who will do a demonstration.
Hi, my name is Eden, and I'm a Senior Data Science Manager here at AWS. My team offers professional services to customers, and we build custom machine learning solutions. We have many customers with strict security and compliance requirements, especially in the financial services industry, and we've helped them achieve speed and scale in getting solutions into production.
Enterprises and organizations in highly regulated industry, such as financial services and public sector, are moving to AWS. We hear from them that they are looking to provide a secure, governed, and compliant way to provide easy access to data science platform. They want to promote experimentation, generate new business opportunities, and innovate. A common misconception is that those highly regulated environments require a trade-off between agility for the data science team and security and compliance of the environment. In this session, we show you how you can have both. You can have the freedom to innovate and execute at speed, and you don't have to compromise on compliance and security. So what will we talk about? First, we'll talk about the challenges encountered when doing machine learning in highly regulated environments. We will then talk about the necessary steps to bridging the gap between machine learning teams and cloud IT teams, one of the core concepts being automation. Finally, we will showcase a new framework called MLMax. MLMax is a set of example templates to accelerate the delivery of custom machine learning solutions to production, so you can get started quickly without having to make too many design choices. And one of the very useful templates that we have in there shows you how you can automate the build of a secure data science environment. So we'll not only tell you about the best practices, but also give you hands-on, concrete end-to-end examples and templates that you can easily use to get started. We have a lot to cover, so let's jump right in. So we know that customers in financial services and public sector have stringent requirements. For example, financial compliance is all about enabling transparency and integrity in the financial markets, while protecting customers and society from financial crimes and ethical threats. But it's more than that. In fact, it helps ensure financial institutions operate responsibly and therefore maintain consumer confidence in financial system. For public sector customers, they're focusing on providing great customer experiences and great services for citizens, and they need to ensure the security of citizen data and offer trust and transparency to achieve that. And for both industries, it means that we have all of those things to consider, all the things that you see here. Not only that, but it's 2021 today, and we know that putting machine learning in production is a challenge. There are all of those different components that you need to think about that are around the machine learning code itself. Things like feature extraction, serving infrastructure, etc. A number of studies have shown that about 85% of the machine learning models that are produced today are never actually brought into production, which is a massive number when you think about it. Every day, I meet customers that show me what they're doing with machine learning, and very often they'll tell me the machine learning model that they build, the library that they use, but they get stuck. They get stuck with this model and ask for guidance on how to deploy it and what they should think about to productionize that model. It's often a lot bigger than what they initially thought. So getting those projects from this research, experimentation phase, this, oh, I have a model that gives me pretty good results on that data that I have right now on my laptop, to a reliable production deployment is actually hard. And the path to make it happen is still unclear and unknown to many. And now, because we are in regulated industries, it gets even more complex. On top of all of those components that need to be thought of and implemented, those organizations have to do even more. Some of the key aspects for highly regulated environments include traceability, methods to trace machine learning model lineage from data preparation, model development, and training iterations, as well as how to audit who did what at a given point in time. Explainability and interpretability, methods that help explain and interpret the trained model and obtain feature importance, so knowing what are the key decision points for that model. Data protection, how to encrypt data in transit and at rest with customer-provided encryption keys. Auditability, how to audit, prevent or detect who did what at a given point in time to ensure malicious activities are blocked or identified early and that we can trace back anything that happened. Compute and network isolation, how to do machine learning efficiently in a customer's private network with no internet connectivity in the cloud. Human reviews. It may be appropriate to have additional trained humans review predictions made by such models before taking any actions. So there is a lot to think about. How do we do it? How do we make sure that machine learning builders can experiment fast, build and train models rapidly, and that this desire for agile experimentation is properly balanced with operational guidelines and cost controls and security? The good news is that this kind of balance between machine learning agility and IT governance can be achieved with Amazon SageMaker and a number of AWS services. So let's break down the key components that you need to think about, and then Eden will showcase a framework that our team at AWS open source to help you get started quickly thanks to automation. When architecting machine learning for regulated industry, we want to keep three important goals in mind. The first one is establishing machine learning governance. The second one is operationalizing these machine learning workloads. And the last one is provisioning a secure machine learning environment. So let's get into a bit more details on those different blocks that you need. Establishing machine learning governance. You need to think about traceability. We talked about that earlier, explainability and interpretability. You also need to think about model monitoring, how to monitor your model in production to protect against data drifts and automatically react to rules that you define. Reproducibility, how to reproduce your machine learning model based on the model lineage and the stored artifacts. The second point is operationalizing your machine learning workload. And there is different things here. Model development workload, how to build both automated and manual review processes in the dev environment. Pre-production workload, how to build automated CI/CD pipeline dedicated to machine learning. Production and continuous monitoring workloads, how to combine continuous deployment and automated model monitoring. Tracking and alerting, how to track model metrics and alert appropriate users if something goes wrong. And finally, the last point is provisioning the secure machine learning environment. And here you need to think about all the things: compute and network isolation, authentication and authorization, data protection, and auditability. Thankfully, we have a number of services that help you at all levels, with the flexibility and the modularity that you need. AWS provides all of these building blocks: infrastructure services in compute, storage, security, networking, so that customers have this high degree of architecture flexibility. For explainability and interpretability, we have Amazon SageMaker Clarify that helps detect potential biases during data preparation, after model training, and in your deployed model by examining attributes that you specify. For instance, you can check for bias related to edge in your initial dataset and in your trained model, and receive a detailed report that quantifies the different types of possible biases. For data and model traceability, we have Amazon SageMaker Lineage Tracking that creates and stores information about the steps of machine learning workflow from data preparation to model deployment. With the tracking information, you can reproduce the workflow steps, track the model and dataset lineage, and establish model governance and audit standards. For monitoring, we provide Amazon SageMaker Model Monitor, which continuously monitors the quality of SageMaker machine learning models into production. With Model Monitor, you can set alerts that notify you when there are deviations in the model quality. To operationalize the machine learning workload and enable self-service, you can use AWS Service Catalog. It allows you to centrally manage deployed IT services and your application resources and metadata. This helps you achieve consistent governance and meet your compliance requirements, while enabling users to quickly deploy only approved IT services they need. A SageMaker project is an AWS Service Catalog provision product that enables you to easily create an end-to-end machine learning solution. For CI/CD in machine learning, you can leverage the AWS Code Suite and Amazon SageMaker pipelines. It's the first purpose-built continuous integration and continuous delivery service for machine learning. With SageMaker pipelines, you can create, automate, and manage end-to-end machine learning workflow at scale. Finally, for automation, we provide AWS CloudFormation, which gives you an easy way to model a collection of AWS and third-party resources, provision them quickly and consistently, and manage them throughout their lifecycle by treating infrastructure as code. To provision a secure machine learning environment, we offer a number of AWS services that are common to many workloads on AWS, such as Authentication and Authorization Service, AWS IAM, and a lot more. One of the key components that we want to focus on today, and that ties all of those components together, is automation. And Eden will tell you about MLMax, a framework that will help you get started quickly with automation.
Thanks for that, Natasha. So it can be very challenging when getting started to know how to create automation, especially in a regulated environment. There are a lot of choices to be made on how to achieve the additional requirements, and a lot of setup and configuration activity to make it happen. So we've been talking about agility, and the last thing you want to do is to have to go through a large architecture and design phase before actually building working software. MLMax is a series of templates for starting a machine learning project, and it avoids having to make design choices on how to architect the solution every time, and ensures that you're following best practices in design. This is not a platform, a service, or a product. It's a guide to getting started quickly and implement some of the services that Natasha just discussed. So let's jump into a demo. So we start off by searching for MLMax on GitHub. And then what you'll want to do is copy the HTTPS URL that we're going to clone down. And then we jump into our local laptop, and we're going to clone that URL. We're going to clone the MLMax repo from down on GitHub. So that's stored on my local laptop. But the next thing I want to do is when we go into AWS, that's not actually going to be available because there's no internet access. So what we do is create a code commit repository for MLMax up on AWS. So this is where we'll store an internal repository of that MLMax code that we just downloaded from GitHub. So we've created a repository, and then we'll just copy that URL for the address so we can copy the code up into that repository. So down back onto the laptop, and then what we do is add a remote to our internal GitHub repository, and then push the code up to that remote. So we'll push it up to that code commit remote, and we'll just wait a second while it uploads there. So we're writing the objects up to the code commit. Just takes a little second. Great, now that's done. So there's a couple of things we need to set up before setting up our development environment. The first one, we want to go to Amazon S3 to create a bucket. So you can call this anything you want. We will call it MLMax. So what this bucket is used for is this is a CloudFormation bucket to store any assets that CloudFormation needs when setting up your environment. So it's a bootstrap bucket that CloudFormation uses. So we'll call it any name you want, and then we'll go and create the bucket down below, accepting all the defaults of the configuration. So that'll take a few seconds to create. And you want to take note of the name of the bucket that you put in, because you'll need that very soon when configuring, when you're setting up the environment. So another thing that we'll need is our key pairs. So we'll go into the EC2 part of the console, And I've created this before. We've got a EC2 key pair, and you just need to take note of the name because we're going to need that for our configuration. This is one I've created before. If you don't have one, create one now. And then just keeping in track that name. Then we'll go back down into our laptop, and we'll go in MLMax, we'll go into the environment module. And so what we want to do is then edit the configuration file. And this is where you put in that key name that we just copied from the AWS console. So the Sydney Summit 2021. And then we put in the bucket name, that Bootstrap bucket that we use from CloudFormation here. So we copy in that bucket name. Just type that in here. And then we save our file, save our configuration file. And that's ready. So then we've got one single command that we run, and then that runs and sets up our complete development environment. We provide a stack name and that Bootstrap bucket name. And what this does is goes and runs our CloudFormation scripts and sets up our complete development environment. So there we go, it's all running in CloudFormation there. And so we're creating that stack. So this stack consists of a Jupyter Notebook instance with SageMaker. It has a demo development instance on EC2 up there, and it has an isolated VPC. So we see it's already created. So one thing we need to do is, because it doesn't have any external internet access, we're going to have to actually copy the dependencies up to S3. So these are the dependencies used by the MLMax code to run S3, to run the pipeline and develop that inference environment. So we're just copying those dependencies up to an S3 bucket that we're going to use later. Another way of doing this is you can do with Code Artifact as well. It helps you copy those dependencies there. Then we go back into the console, and there's a few extra things we need to set up in terms of security that haven't been set up before. So we just add administrator access to our EC2 instance. And then the other two things we need to do is create two VPC endpoints for our VPC. So one thing we need to do is create a step functions VPC endpoint. So we're going to, from the EC2 instance, we're going to use AWS step functions, and we need access to that from our EC2 instance. And that's not available because there's no internet access. So we set up this VPC endpoint, and here we'll select the security group that was created automatically. And we'll just go down and then create this VPC endpoint that you can use to connect to step functions. We'll just scroll down, accept all the defaults, and then create that endpoint. And additionally, we need to set up a second endpoint. There's some others there that have already been created for you, but these are just extra ones we need to add in. We need a CloudFormation endpoint as well. So here we'll go in and very similarly select our VPC, both of the availability zones, and that same security group. And we'll do exactly the same thing to create a CloudFormation VPC endpoint. So great, that's created. See, it's pending. And at this stage, this is where you can automate all the steps up until now, and you want to hand over the SSH key to your data scientists. And it's recommended to do this in an automated way, rather than manually like we're doing now. So we'll just check that, yep, those endpoints have now been created and they're available. So we're ready to go with MLMax. So one thing what we'll do is once they're created is we'll go back to our development laptop. But first we need to look at the stack, and then we can find the instance ID of our EC2 instance. So we're looking, you can see here, this is the EC2 instance that's been created. And we just copy that physical ID because we'll need it to log into that instance. So back on our laptop now, and I'm going to set up the SSH configuration so it's easy to log in whenever you want. And so just edit that SSH config file. So here it is. And so we put in that host name, which is that ID that we got copied. And then we put in the identity file of that key. And then you'll notice here that we use a proxy command to SSH into it. So we use Systems Manager, SSM, to log into the instance. And that's handy because it means we don't have to have internet access in our VPC, and we don't have to open port 22, and it's a very secure way to log in. So now we've SSH'd into our instance. So we're in our development environment. So we activate a Conda environment to work in, a Python 3 Conda environment, and we're ready to go. So first thing we'll do is go back to that internal code commit repository. So we're looking at that repository. And to be able to access this repository, we want to set up our code commit credentials. So we'll just go look at the docs to copy those credentials. So we want to copy this AWS CLI credential helper using for git configs. So we'll copy those credentials here, and we'll just take those over to our EC2 instance, back into the console, and we'll type those in and set up those credential helpers. And so what that does is now we can clone our repository down from the code commit repo. So we'll cut and paste here that address for that internal repo. And great, all right, now it's copying down, and we've got the MLMax code on our EC2 instance. That's great. So remember before that we use those dependencies, we need to do those as well, but just we're setting the region name in the AWS configure. But yeah, so we're taking those dependencies that we copied up before to S3, those we need to pip install them, and we're then copying those down onto our local EC2 instance, because remember again, because we don't have external internet access. Again, using Code Artifact can make this easier and managing it through a team. But in this case, we just copied it up to S3. So now, yep, those are copied down. Let's just have a look, make sure they're all here. Yeah, we've copied them onto our local EC2 instance. So we just change directory into there. And what we're going to do now is install all of those using pip install. So we install all of those dependencies into the local. And notice, yeah, it's in this Conda environment that we're installing them. Yep, so we jump into there. All right, so now it's ready to go. We're ready to go with all the dependencies on that instance. So the next thing we do is, because we're working in the Sydney region, we create another configuration here for the Sydney region, which we've done with our AWS configure as well. Let's just check that that's set up. Yep, that's set up with we've got a default pipeline name. And then we'll also look that, yeah, we've set to the default region is the Sydney region. So the next thing we do, we run these create pipelines for training pipelines and inference pipeline now. And what this does is it creates all the complete CloudFormation for running your training and inference pipelines. So they're all set up locally. And then all you need to do is run the deploy command, which then goes and runs those CloudFormations up in using step functions. So there we go. We're executing those CloudFormation scripts. So it's up and running those. So we're creating the training pipeline stack. So that's using these training pipelines use the step functions as well as Amazon SageMaker processing jobs. And we're just creating that stack now. So yeah, we've run that training stack, and so that's all done. And yeah, if you go look at back on the console, we can see that that's all been created. So we've got a stack for our training pipeline as well as our inference pipeline, and those are step functions pipelines. So if we go back to the console, we can run those ourselves so we've got these commands to run them. First, the training pipeline. So if you jump in here, you can see that it's currently running the pre-processing step of our pipeline, and now it's finished. So those are the evaluation results that we've got. So it's run the pre-processing, training, and evaluation through the step function. So yep, that's the training pipeline. So now the model's saved in S3, so we can now run the inference pipeline. Now the model's trained and all ready. So there we go, inference pipeline run. It's all good. So that's running the inference pipeline now. So if we go back to the console, check out the inference pipeline, you can see it's running. Look that it's running the pre-processing step currently. And that uses the identical code to the training pipeline for pre-processing for consistencies. So it's running exactly the same pre-processing step in batch. Now it's running the inference, and it's in progress. And we'll just jump into that Amazon SageMaker processing job, which is used to run these steps. And we can see that instance name. And so that's in progress at the moment. If we scroll down to the bottom, we've also added a key here that allows you to have that traceability of the step function that's executing this processing job. So there's full traceability throughout the pipeline, which is quite important. So there we go. That's run the inference job, and we're ready. So we've set up a complete environment, as well as run a complete training pipeline and inference pipeline, all in a short space of time. MLMax is available open source on GitHub. Just search for MLMax and you'll find it. We also welcome requests and feedback via GitHub issues, as well as contributions. Thank you so much for joining me today. I hope this session has been insightful and has inspired you to keep the learning going after the summit with resources from AWS training and certification. When you're ready, prepare for the Certified Machine Learning Specialty Exam, which validates your skills and provides an industry-recognized credential. For more information, visit this link, aws.training/machine learning. And finally, we would appreciate if you could fill out the session survey so that we can better understand the topics and services that you would like to learn more about and get in touch. Thanks again, and enjoy the rest of the summit online.